Hello guys, good evening everyone. Welcome to the GATE 2024 Rankers Monsoon course, the free course on YouTube. Okay, to make you utilize this monsoon sessions and get you scoring by learning the most important topics. Yes, we are covering up the most expected and important topics for the GATE examination this monsoons, and here in the digital electronics, this is the 5th class, and of course you all must be aware that counters is definitely one area where question is expected. You can say, there's 80-90% chance. Of course, first of all, from digital, surely you get a question from sequential circuit, and out of which is 80-90% chance you get a question based on counter or around counter, somewhere using it. So that is why this topic becomes important. Directly you expect the question, mostly 2 marker, right? So very good evening everyone. Good evening Kishantu, Shravan, Nishu, right? Yes, so it is important for all the branches. Okay, chalo, okay, be it EE, ECE or even computer science. Let's get moving ahead and let's learn the top 11 questions, and with these 11 questions, of course, you'll revisit all the concepts required to get hold on the counter. So let us get started quickly. Okay, okay, and here it is. All right, so first of all, guys, this Sunday, that is just day after tomorrow, 16 July, starting from 9 a.m. Okay, starting from 9 a.m. you get a chance to get up to 90% scholarship on the GATE preparation programs. Yes, appear in the BYJU'S exam prep, national scholarship test, and take a next step towards your success in GATE. Get the guidance of the best faculties of the nation, and that too with huge scholarship. Just have to prove yourself this Sunday. Okay, for the test starting from 9 a.m. Register now on the BYJU'S exam prep app. Also, guys, again on the BYJU'S exam prep app, okay, a free mega workshop for you, and this time specifically not the complete strategy, but this workshop is going to talk about the strategy, the tips and tricks to secure full marks in aptitude in GATE. We know it's a light-hearted subject, but at the same time it is very important because of the weightage. Okay, so how to spend less time and still score more in this particular subject, I'm going to give you the tips. Tuesday 7:30 p.m. on the BYJU'S exam prep, you can join me live directly. Right, very good evening Prem, Bhaskar, Vikas, Bhanu Prakash, very good evening all. Okay, so guys, let's get started with the first question. Okay, and the first question, okay, is I'm starting with a design of a 3-bit binary up counter. Okay, let me also mention one more thing. Let me start with synchronous first of all. 3-bit binary synchronous up counter using T flip-flops. Okay, now there can be questions, and there have been questions in GATE around designing as well. So let's get started with this, and if you understand one designing problem, okay, rest all can also be dealt. I will go to the rest questions also. Okay, but it's a simple procedure. Let's learn it up. Design a 3-bit binary up synchronous counter. Now, what do you mean by synchronous counter? Synchronous counter is the case where all the flip-flops, okay. Yes, Bhanu, we'll plan mathematics also next, definitely. Synchronous counter is the key. Okay. Yes, Bhanu, we'll plan mathematics. Yes, sir. Okay. Right. So synchronous counter is the case where all the flip-flops, like I told you yesterday also under the synchronous finite state machines, okay, all flip-flops, they use common clock. All the flip-flops, they use a common clock. Right. Okay. Okay, chalo. Okay, so all the flip-flops will use a common clock. Now I want to design a 3-bit. Now 3-bit will have how many states? Okay, if you have a 3-bit counter, you can have a maximum of 2 power 3, that is equal to 8 states. Okay, that is equal to the 8 states. What are those 8 states? First let me start by the state diagram. Okay, first let me start by drawing the state diagram of this. Here it is. The state diagram is shown below. The 3 bits, the lowest count will be 0, 0 and upper one will be 1, 1, 1. So 3-bit counter, up counter, I means a counter which continuously cycles through. Cycles means whenever the clock edge comes, because we are going to design it using flip-flops, and flip-flops will trigger on the edge of the clock. It can be positive edge or negative edge, anything. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1 and back to 0, 0, 0. It will restart. It will keep counting till it is powered on. It will keep counting till it is powered on. So after the highest count 1, 1, 1, it will go to back to 0, 0, 0 and keep on moving. Now this is the state diagram. Okay, yesterday also in the finite state, because ultimately what is counter? Counter is a type of finite state machine only. Okay, so yesterday we were dealing separately with the state diagram, good variety of question. Today we will separately deal with the counter based question only. Okay, now let's put it into the table. This is the state diagram. Let's put it into the characteristic table now. Okay, characteristic and excitation, both I will write down here. So see, I will write down the current state, and corresponding to the current state, I will write down its next state, and then we will fill up these entries. Okay, so dear, if the current state is 0, 0, 0, have a look into this. If the current state is 0, 0, 0, what's my next state? Definitely 0, 0, 1. What comes after 0? 1. What comes after 1 is 2, if I say in decimal. Then 3, 4, 5, 6, 7, back to 0. Okay, so suppose if my current state is 0, 1, 1, that is 3. My next state would be 4, that is 1, 0, 0, and etc, etc, etc. Okay, etc. That's what, this table is showing you. Every current state and its corresponding next state. Okay, now you have all learned and studied about flip-flops. Okay, just 2 classes I spent on the flip-flops also. One is the complete concept of latches and flip-flop, and one is the questions based on the flip-flops that we have done. A good variety of questions also done. Okay, now what we need to do here is, we need to design it using T flip-flops. Now what we know about T flip-flops? If T is 0, the state doesn't change. If T is 1, the state is toggled. Toggle means complement. Okay, that's what we know if the T input is given. But here, I need to derive the T input. I know what to do. I know what the circuit should do. Here I am designing the circuit. Okay, so you have to think reverse. Like, look into the Q2. Okay, for the first row, look into the Q2. Okay, it was 0. Q2 plus is also 0. The next state is same as the previous. That will only happen if the T input is 0. If the T input is 0, right? In this case, we call this flip-flop input. Okay, this is the flip-flop input, and we are going to call it as excitation signal. Here we are deriving what is known as the excitation signal. Okay, what input to be applied to the flip-flop? How you should excite the flip-flop so that the given state transition occurs. Okay, so given state transition is 0 to 0, that is no change. Okay, now let me complete this for all the values of the Q2. Okay, 0 to 0, no change. No change pe T0. 0 to 0, again no change. Sir, 0. Okay, 0 to 1. Now look into this, guys, very carefully. 0 to 1. Okay, toggle. Q2 has toggled. Okay, and that is only possible if I take the T input as 1. So corresponding to this particular state transition, T input should be 1. Then only this is possible. Okay, next 1 to 1, same. 1 to 1, same. 1 to 1, same. Same means write down the T input as 0. Lastly, you see 1 to 0. 1 to 0 is also toggle, is also a complement, and that can occur if you take the T input as 1. Okay, so based on the Q2 transition, I have decided the T2 input. We can call it as TQ2 input also. That is the T input of the Q2 flip-flop. Clear? Now, similarly, we need to complete this for the Q1 as well. We need to complete this for the Q1 as well. Okay, so look into the Q1. 0 ka 0, same. 0 ka 1, toggle. Same pe 0, toggle pe 1. Next देखेंगे 1 to 1, same. 1 to 0, toggle. Okay, next 0 to 0, same. Next 0 to 1, toggle. Next 1 to 1, same. And next 1 to 0, that is toggle. So TQ1 entries are sorted now. Okay, now same thing we need to do with the LSB bit as well, that is the Q0. Okay, looking into the change at Q0. So 0 to 0, sorry, Q0 देखना है. तो 0 to 1 toggle. Here please एक बार देख लेंगे. 0 to 1 is toggle, 1 to 0 again toggle, 0 to 1 again toggle, 1 to 0 again toggle, again toggle, again toggle, again toggle, again toggle. So LSB will every time just toggle. LSB will every time just toggle. That means the TQ0 input is always 1. It is always in the toggle mode. The TQ0 input is always in the toggle mode. The TQ0 always in the toggle mode. Okay, it is always in the toggle mode. Okay, now what is the next step? What is the next step? Okay, next step is in designing any counter, write down the excitation signal. Okay, write down these excitation signals as the function of the current state, as the function of the current state. Okay, so let us start with the TQ2. Let us start with the TQ2. Yeah, simply let me call it as T2. Let me simply call it as T2. Okay, and I will write down the simplified expression only by drawing its K map. right, as a function of current state. As a function of current state. So what is the current state? Q2, Q1, Q0. Current state is Q2 and Q1, Q0. That is the current state, dear. And TQ2 0, 0, 0, 1. Okay, fill the K map 0, 0, 0, 1. Only fill the ones. That is sufficient. Next 0, 0, 0, 1. So 0, 0, 0, 1. Okay, the last two bits, the last two columns are swapped in K map now because of the gray codes. Okay, now let me write down these entries. Yeah, let me write down. This is Q2, so 0 and 1. That is Q2 bar and Q2. Okay, and this is Q1, Q0 combination. Okay, here I have to write down Q1, Q0 combination. So Q1 bar, Q0 bar, 0, 0. Then I will write down 0, 1. And then I will write down 1, 1 because of gray code. And then I will write down 1, 0. That is Q1, Q0 bar. Okay. Okay, and now this clearly suggesting me that this is the place where Q2 is high, right? Where is Q1? Q1 is seen at these two columns and Q0 is seen at these two center columns. So this will be Q0. And now let me make the pair. Okay, there is a pair. Okay, a vertical pair coming up here, and that vertical pair, it is in Q1, Q0. It is in Q1, also in Q0. So that is Q1, Q0. Clear, everybody? That is known as the Q1, Q0. That is known as the Q1, Q0. So what is the value of T2? The value of T2 is Q1, Q0. The value of T2 is Q1, Q0. Same thing I need to do with the T1 now. Same thing I need to do with the T1 now. Okay. Same thing I want to do with the T1 now. So let's come to the T1 now. Okay. And again, complete the problem by drawing its K map. Okay, so what is next? Okay, T1 0 1 0 1 0 1 0 1, alternate reading it is the alternate reading. So I will feed here 0 1 then 0, swap hoga 0 then 1 here. Okay, 0 1 again 0 1, and then let me do this possible pairing, and here it is a quad actually. Here it is a quad. Okay, this one is Q2, we know. Okay, this one is for Q2. So where is the Q1? This is the Q1, and Q0 is the center two columns. So this is the Q0, and this quad is clearly inside the Q0. This quad is clearly inside the Q0, right? So what is the value of the T1, dear? The value of the T1 input is equal to Q0. The value of the T1 input is equal to the Q0. Okay, ji? Is equal to the Q0. Acha. Now what about T0? What about T0? Do I need to solve for T0? Not at all, guys. Do I need to solve for T0? Have a look into this. It is 1 1 1 1 1 1 1 1 1. It is always 1. It's constant actually, so need not solve. Okay, T0 is just equal to 1 always. So no K map, no simplification required. That is equal to 1. Okay, now next step will be drawing its hardware, drawing its logic circuit diagram. Okay, so have a look into this circuit diagram. Have a look into this particular circuit diagram. Okay, this is the T0 input, this is the T1 input, and this is known as the T2 input. This is the Q2 output, Q1 output, and Q0 output. Okay, this is the flip-flop correspondingly named as 0, 1, and 2. Correspondingly named as 0, 1, and 2. Okay, where T0 is always high. Okay, so what is the T0 input? That is equal to 1. Okay, what is the value of the T1 input? T1 is the Q0, current state of Q0. So देखो, ये रहा Q0 output, and I have taken it here. ये आ गया ना? This is the Q0 output. That Q0 output comes here. That Q0 output comes here. There is some type errors. ये नहीं आएगा. It will directly go. It will directly be connected there. ये क्या कर दिया है इन्होंने? T1 is equal to Q0. हाँ, correct है. T1 is equal to the Q0. Correct. So this is not going to come. So I will remove it. Clear? Okay, so T1 is equal to Q0. What is the next? What is the next? T2 is Q1, Q0. T2 is Q1 Q0. Okay, so I take Q1, this is Q1, and from there already Q0 is coming. These two are multiplied by the AND gate. Here I get Q1 Q0, and that is fed to the T2 input. This is the circuit diagram. This is the circuit diagram. Okay, using 3 flip-flops and 1 AND gate. And not only this, guys, let me tell you one more thing that see, T0 was equal to 1. T1 was equal to Q0. यही देखा था ना, T1 was Q0. T2 was Q1 Q0. T2 was Q1 Q0. What is this Q1 Q0? Okay, अगर आप T2 निकाल रहे हो तो it is the output, previous two outputs, Q1 Q0. Okay. Okay, this is a 3-bit counter, right? Suppose, guys, if I have to design a 4-bit counter, suppose I am now going to design a 4-bit counter. I am not going to draw the table and state diagram again. I will tell you the direct result. Even for 4-bit counter, you will get the similar results. Even for the 4-bit counter, you will get a similar result. LSB always toggle, T0 equal to 1. T1 equal to Q0, same result. T2 equal to Q1 Q0, same result. But only thing, because it is 4-bit, there will be 4th flip-flop. There will be 4th flip-flop, and its input is going to be, any guesses, guys? What is going to be its input? I am going to calculate 3, T3. So 2, 1, 0, Q2, Q1, 0. Q2, Q1, 0. Okay. Q2, Q1, 0. Now, if I compare the hardware, okay, here in 3-bit, I need 3 flip-flops. In 3-bit, I need 3 flip-flops. Okay, in 3-bit, I need 3 flip-flops plus 1 AND gate. Okay, plus just 1 AND gate, which is shown in this picture. Okay, 1 AND gate of 2 input. Okay, 2 input AND gate. Correct? What do I need here? Of course, it is 4-bit, so every bit needs 1 flip-flop. So 4 flip-flops plus how many AND gates? Plus how many AND gates? Do I need a 3-input AND gate here? No, I don't need a 3-input AND gate here, because out of Q2, Q1, Q0 is already realized. Okay, this is Q2, and Q1, Q0 is already implemented using 1 AND gate, na? Okay, so why to repeat that? Okay, Q1, Q0 is already implemented. Okay, use that AND gate output and then use just one more AND gate of 2 input to multiply these two. Clear, everybody? So here I just need 2 AND gates only, and of 2 input only, right? 2 input AND gates. So I want to also give you a comparison, okay, between synchronous and ripple. I also want to give you a comparison between the synchronous and ripple. Okay, ripple. Next, I will take the ripple also. So if I want to talk about a synchronous n-bit counter, okay, if I generalize a synchronous n-bit counter, okay, n-bit synchronous counter, 2 important points to be noted. Number 1, it will n flip-flops, right? It will use n flip-flops. Number 1, I will write down its hardware. Okay, it will use n flip-flops, right? Plus how many AND gates? Okay, if it is 4 flip-flop, 2 AND gates. If it is 3 flip-flops, 1 AND gate. So AND gates are 2 less in number. Okay, so n minus 2 AND gates. Right, where the AND gates are 2 input only. We don't need multi-input, that is also fixed. N minus 2, 2 input AND gates. Okay, n minus 2, 2 input AND gates. Okay, second point. Acha, before I go to second point, okay, very, very good evening. Before I go to second point, that is about the speed. Okay, let's go to the ripple design as well. Okay, we'll come back to this. Okay, so now how many flip-flops and how many AND gates in a ripple counter? Okay, so now I present to you example of a 3-bit ripple up counter. This particular circuit is a 3-bit ripple up counter. Now, ripple is a category of asynchronous. What happens in ripple? Okay, the clock is fed to, please remember 2 important points. Clock is fed to only the LSB flip-flop. The clock is fed to only the LSB flip-flop. Clear? Only the LSB flip-flop. Next, okay, how the other flip-flops will work if the clock is only fed to LSB. This one is LSB, right? The output of every flip-flop will go to the clock input of the next flip-flop. So second point, output, right, of a flip-flop, okay, output of a flip-flop drives the clock of the next flip-flop. Okay, so that is going to be fed to the clock of the next. It can be Q, it can be Q bar, anything. I will tell you what will be the change if you change from Q to Q bar, but Q or Q bar output will be going to the clock input of the next flip-flop. Number 3 point to be noted about ripple counter is all the flip-flops, okay, must be in toggle mode. Now, for a T flip-flop, dear, what is a toggle mode? For a T flip-flop, what is toggle mode? Toggle mode means T input 1, because whenever T input is 1, the state will toggle. So if you look into this diagram, all the T inputs are equal to 1. All the T inputs are equal to 1. Okay. All the T inputs are equal to 1. Okay. Now for once, let me explain you the working. Then we will summarize something here. Okay. So how it is a 3-bit up counter or down counter, wo samajhna padega na. Okay. So let us take this Q2, Q1, Q0. And always any device by default will start with the reset power on state, and that is all flip-flop 0, 0, 0. Okay. Now I need to see what is next. Now I need to see what is actually next. Next samajhna padega. So what is going to be the next state? Okay. See, clock. What is clock? Clock is a periodic waveform that you apply to the LSB flip-flop, right? And it's a negative edge triggered flip-flop. So whenever clock negative edge will come, and clock negative edge will keep coming after certain time, because it is periodic waveform, after every fixed time the clock negative edge will come. Whenever clock negative edge will come, T input to 1. So here you have to only wait for the clock, because T input is fixed. What is the T input? Is 1. T input is fixed and that is equal to 1. The T input is fixed and that is equal to what? That is equal to 1. You don't have to worry about input. Whenever clock edge comes, clock negative edge comes, toggle kar dena hai. So this clock comes to the LSB flip-flop. Whenever clock comes, LSB will toggle. LSB will toggle. It is 0, now it becomes 1. Now, what is the change on the LSB? LSB has changed from 0 to 1. And what is the 0 to 1? It is a positive edge. Why I am looking into this? Because, dear, whatever is the Q0, that goes to the clock input of the next flip-flop. This flip-flop will only toggle when the clock negative edge comes. When the clock negative edge comes. But right now, what is the transition? 0 to 1. 0 to 1. 0 to 1 is a positive edge. So will this flip-flop work? No, it will not work. It will not work. That means it will remain in its previous state. It will remain in the previous state. Okay, sir. The previous was 0, remains at 0. Okay. Next, what is the transition on Q1, dear? What is the transition on Q1? By Q1 pe to there is no transition. 0 to 0, there is no transition. It's a flat line. It's a flat line. So will this flip-flop work? No. For this flip-flop to work, here it needs a negative edge. We need a negative edge Q1, and Q1 is not showing any type of edge. Okay. So next flip-flop will also not work, and Q2 will remain in the same state. It was 0, remain at 0. Okay. So moral of the story is, once again the clock negative edge will come. You first higher, now second clock negative edge will come. Whenever the next edge will come, okay, LSB will toggle. Now see, LSB toggles. So there is a negative edge. LSB now toggles and there is a transition which is 1 to 0. There is a transition which is 1 to 0. That is negative edge. And dear, if there is a negative edge at Q0, so Q1 will toggle now. Q1 will toggle. Okay, isko toggle kar diya. But what is the transition at Q1? 0 to 1. 0 to 1 is positive edge. I don't want positive edge. So next flip-flop will not change. So that's what moral of the story is. On every clock, okay, first toggle the LSB. Okay, toggle the LSB. And then see, if there is a positive edge at LSB, nothing will happen to the next bit. But if there is a negative edge, next bit will toggle. Whenever you get a negative edge at a particular bit, its corresponding next bit toggle karte jana hai. That is the philosophy now. So 0 to 1 positive edge. So next, no change. And if there is no change, so there is no transition, there is no negative edge again. So next also no change. Okay, next also no change. Next, keep moving ahead. Okay, clock will again come. After a certain time, clock negative edge will come. LSB toggles, and this time again 1 to 0 negative edge. Because it's a negative edge, so next bit will also toggle 1 to 0. So dear, 1 to 0, this is also a negative edge. So its next bit will also toggle. Whenever you get a negative edge, its corresponding next bit will toggle. Yahi to karna hai. Yahi to karna hai. That is how it is simple now. Okay, now again after some time, clock negative edge will come. That will keep coming automatically. So LSB toggled. 0 to 1 positive edge. So no change in the next bit. 0 to 0 no edge. So again no change in the next bit. Next, this becomes 0. Okay, LSB will again toggle, and then it is 1 to 0 negative edge. So next will toggle 0 to 1. Okay, 0 to 1 is a positive edge. Okay, so at positive edge, no change. The next will remain same. It will be 1. Okay, next. Again LSB toggle. 0 to 1 is a positive edge, so no change in the next. 1 to 1 there is no edge, so there is again no change in the next. It's up counter. Now I have reached 111. What happens after 111? वो भी देख लेते हैं. After 111, again clock negative edge will come. Toggle. Okay, toggle. So the LSB becomes 0. 1 to 0 is a negative edge. So next also toggle. So next Q1 also 1 to 0. That is also a negative edge. So next will also toggle. 1 ka hua 0, and then it's all 0. It is 0 0 0. It is 0 0 0. So back to the initial state. That is how it is a complete 3-bit up counter. It is a complete 3-bit up counter using ripple mode. Okay, using the ripple fashion. Okay, the clock propagates from LSB to the MSB. What is the advantage here? For 3-bit ripple counter, I only need 3 flip-flops. There is no extra hardware required. No AND or XOR, nothing is required. Okay, for 3-bit, I need only 3 flip-flops. For 4-bit, suppose you want to design a 4-bit ripple counter. It is very simple. Okay, here there will be one more flip-flop, T3 input. T3 will be 1, all flip-flops in toggle mode, so T3 will be 1, and Q2 output will go here. Q2 output will go to the next clock. That becomes a 4-bit ripple counter. No extra logic circuitry is required. Okay, so that is one advantage of the ripple counter. It has less hardware. Okay, it has less hardware. Thank you so much, Chatu. It has less hardware as compared to synchronous. Okay, as compared to synchronous. Okay. So let me write down one more point here. If I talk about the n-bit ripple counter, dear, if I want to talk about the n-bit ripple counter, number one, if I want to compare the hardware, okay, it will only have n flip-flops. Okay? It will only have n flip-flops. Okay, it will only have n flip-flops. Okay. But next point, speed. Okay, speed की अगर बात करें, okay, speed की अगर बात करें, okay, so for speed I need to know, okay, for speed I need to know what is the total propagation delay. The total propagation delay. So see, what is the total propagation delay? My clock will come to LSB. Okay, first LSB will toggle, then only next can toggle, then only next can toggle. Okay, then only next can toggle. So what is the total delay involved? Worst case total delay involved in this case. Okay, one by one the flip-flops are working. Okay, in synchronous all work at the same time. Okay, suppose this flip-flop needs 10 nanoseconds. The first 10 nanoseconds for its completion. Then after that next will start if there is a negative edge. 10 more nanoseconds, and then after the next will start 10 more nanoseconds. So total 30 nanoseconds. Total 30 nanoseconds. So like that I can say the total propagation delay will be equal to delay of one flip-flop. Suppose that is TFF. Suppose that is a delay of one flip-flop TFF multiplied by n, multiplied by the number of flip-flops. There it is 3-bit, so 3 flip-flops, so into 3, 10 into 3, but in general it is n TFF. Okay, and then by the design timing constraints we know that, okay, the time period of the clock must be chosen. The time period of the clock must be chosen so that it is greater than equal to the total propagation delay. Okay, the clock, okay, should be there. Okay, the next clock will only come after one operation is completed, and one operation is completed in TPD time. Okay, so what is the minimum time clock period? Okay, at which the circuit can work, that is equal to TPD. That is equal to TPD, and TPD here is equal to NT flip-flop. Acha ji, NT flip-flop. Now, what is the clock frequency then? The important formula. What is the maximum clock frequency? यहाँ से question बनता है. The maximum clock frequency is 1 upon minimum time period. Frequency is 1 upon time period. If time period is minimum, frequency is automatically maximum. So maximum clock frequency is reciprocal of this 1 upon NTFF. Is 1 upon NTFF. This one is an important formula. This one is an important formula. ठीक है. So I'm not explaining you this clock constraints by drawing the waveform. If you have any doubts, please let me know, because I want to focus more on counter. Okay, the delays and all I've explained in earlier sessions also. Okay, so let's take down this important formula. Clock frequency is 1 upon NTFF. Okay, NTFF. On the same hand, okay, this is the highlights of ripple. We were on to synchronous also. Hardware we saw is more in synchronous, but speed is also more. In case of synchronous, dear, speed is also better. So if I write down the speed parameters here, TPD here will be TFF. The total propagation delay is equal to propagation delay of single flip-flop, dear. The total propagation delay is equal to delay of single flip-flop, because here, look into this. All the flip-flops are operated by the common clock. All the flip-flops are operated by the common clock. All the flip-flops are operated by common clock. What does that mean? Okay. Whenever clock edge comes, and suppose every flip-flop take 10 nanoseconds, all are ready at the same time, all are active at the same time. In ripple, they will be active one by one. But here all are ready at the same time. Okay, so clock ka edge aaya, suppose this is the time clock edge comes. Everybody needs 10 nanoseconds. So just after 10 nanoseconds after this clock edge, just 10 nanoseconds after this clock edge, all of them will make the transition at the same time. All of them will make the transition at the same time. So the total delay is also 10 nanoseconds only. The total delay is also 10 nanoseconds only. Of course, there might be a small delay of AND gate, but that's usually very negligible in terms of, if I compare to the, especially if I compare to what? Just a second. Yeah, what I'm telling you, there can be AND gate delay, but that is usually much negligible as compared to the delay of flip-flop, so that can be skipped here. Okay, so what is the total propagation delay? It is equal to TFF, right? What is TFF? Let me write down here, right? TFF, here I need, TFF se mera matlab hai, TFF is T clock to Q, right? That is equal to propagation delay of each flip-flop, Okay, we also write down the propagation delay of flip-flop as clock to Q. Okay, the time at which clock edge comes, and after how much time I get the Q output. That is what is the delay. Okay? That is what is the delay. Okay? So now, as per the design timing parameters, T clock should be greater than equal to TPD. That means the minimum time period of the clock that can be chosen here is equal to TPD, and TPD is TFF. So what is the maximum clock frequency? Is 1 upon TFF, 1 upon this reciprocal of this. That is 1 upon TFF. Clear, everybody? Right? Okay. Okay. If possible, I'll take a question on that, Chandrasekhar. Okay. There was a question on it once in BSNL JTO exam, I remember. Okay, chalo. Okay, now let me first continue this. So this is the comparison between speed and hardware. Synchronous has more hardware but better speed. Less delay, better speed. Okay, but if I talk about ripple, less hardware means less costly but slow. Okay, more delay. Okay, so this is more. Okay, this is more as compared to synchronous. That means it is slower as compared to synchronous. Okay, it is slower as compared to synchronous. Okay. Chalo. Acha, also guys, one more thing with respect to ripple I want to tell you. Okay, before we go to the next question. One more thing for the ripple I need to tell you. Have a look into this. Okay, the flip-flops are negative edge triggered. And there is a connection from Q. There is a connection from Q to negative edge. Okay. There is a connection from Q to negative edge. So देखो, ripple counter को थोड़ा सा generalize करते हैं. Let me mention here, what is the type of flip-flop? What is the type of edge? Okay, what is the type of edge triggered flip-flop? Right, and which output is taken? So I have taken in the first story, dear. In the first story, I have taken the Q output and the flip-flop was negative edge. Okay, and the flip-flop was negative edge. Under this case, okay, what is the result? The result was a up counter. हमने prove किया ना? The result was up counter. The result is equal to the up counter. Clear? What is the result? Result is the up counter in this case. Okay, result is the up counter. Now suppose if I take Q output only, but the type of flip-flop was positive edge triggered. The type of flip-flop was positive edge triggered. Then you will be seeing the result as down counter. If any one parameter changes, you will be seeing the result as down counter. इसको थोड़ा और simple करेंगे. Okay. Suppose the flip-flop is negative edge triggered only, like case 1, but Q is replaced by Q bar. That means you take the connection from this. That means you take the connection from this Q bar. Okay, all connections from Q bar. Then again it will be down only. Then again it will be down. Okay. Similarly Q bar, but positive edge. So it will again become up. It will again become up. It will again become up. Okay. Now I will write down a simple shortcut for this. Okay. I will write down a simple shortcut for this. Okay. The shortcut is, suppose Q output is 1. Okay. And type of edge, negative edge को 0 बोलेंगे. ठीक है. तो Q output को 1 लिखेंगे, Q bar को 0 लिखेंगे. Right. Negative edge of course will be named as 0. Positive edge will be named as 1. Okay. Positive edge is named as 1. Okay. Now look, where do you get the up counter? Okay. Where do you get the up counter? At 1-0 combination. 1-0 या 0-1. Whenever both are different. Okay. Whenever both are same, 1-1 or 0-0, you get the down counter. Okay. You get the down counter. The shortcut कुछ ऐसा है. Shortcut कुछ ऐसा है. Okay. Shortcut कुछ ऐसा है. Okay. A simple trick to remember it. A simple trick to remember it. Okay. Let Q be 1, Q bar be 0. Okay. Also let positive edge equal to 1, negative edge equal to 0. Okay. What you have to do? You have to just do the XOR. You have to just do the XOR of output. Okay. You have to do the XOR of output with the type of edge. Okay. After doing the XOR, right? After doing the XOR, right? If the XOR result is 1, okay, then you will get up counter. Then it is up counter. If the XOR result is 0, then you have down counter. Then you have down counter. Then you have the down counter. Clear, everybody? Then you will be having the down counter. That is a simple shortcut to remember this. That is known as a simple shortcut to remember it. That is a simple shortcut to remember it. Okay. Now, let me come to hello dear. Now I think it should be audible. Okay, let's check it out once. It should be audible now. Hello dear. Now I think it should be audible. Yes, it is correct. Yes, it is. All right. Chalo. Okay. So yeah, so what I was trying to tell you, that this is a circuit diagram given and we need to determine what type of counter, mod 8, mod 9, etc. Okay, forget this additional circuitry, look into the top. There are 4 JK flip-flops and note the connection. Okay, Q output goes to the negative edge. Okay, Q output goes to the negative edge. Okay, so what type of counter it should be? And all the flip-flops are in toggle mode. Dekho, all JK is 1. All JK is 1. Right? All these JK is 1. Right? JK equal to 1 means toggle mode. Na? So it is clearly a ripple counter. But what type of ripple counter? It is clearly a ripple counter. But what type of ripple counter? There is the connection. There is the connection from Q to negative edge. There is the connection from Q to negative edge. Q matlab 1. Okay, negative edge means 0 and I will do the XOR of this. 1 XOR 0 is 1 and whenever the output of XOR is 1, it should be a up counter. It should be a up counter. Very clear, it is a up counter, right? Okay, but 4-bit है ना, तो 4-bit can count 16 states. 4-bit can count 16 states. So if this circuitry is not given to me, okay, then it should be a mod 16 counter. But what is the role of this circuitry? Okay, why it is not mod 16? Because there is some extra circuitry and the output of which is going to the clear input. Now, what is the role of clear input in the flip-flop? Okay, what is the role of clear input? And if it is not mentioned by default, it is asynchronous clear. It simply means that, and that too it is active low. ये देखना, ये bubble है ना? Okay, ये bubble है ना? Okay, right, I'll explain you this separately. What do we have here? Okay, what do we have here? This is CLR with bubble. Okay, what is this? Okay, this is known as active low, clear, or also known as reset input. Active low, clear, or reset input. Active low, bubble is represent meaning active low. That means whenever you send a low signal here, then the flip-flop will reset. Active low, it will be active once you send a low signal. Okay, whenever you send a low signal here, the flip-flop will be active, independent of input. Whether the input is 1, 1, 1, 0, don't care. Flip-flop will 100% reset. Okay, and these pins, unless and until mentioned, these pins will be asynchronous. Okay, that means the flip-flop will reset immediately independent of the clock. Okay, what is the meaning of this asynchronous? This asynchronous means flip-flops will reset independent of clock. वो clock का wait नहीं करेंगे. वो किसका वेट करेंगे? ओके, वो वेट करेंगे इस इनपुट का. Whenever you send a low signal here, the device will reset without waiting for the clock. Okay, now what is the signal that is going to be fed here? Okay, that is derived using this circuitry. So now let me first understand, let me first trace this circuitry. This is the Q3 input, this is the Q0 input, sorry, this is the Q2 input, and from here I have the Q1 input and this is further Q3 input, correct? Further Q3 यहाँ पे आ गया. ठीक है, right? अच्छा देखो, one thing is very clear. One thing is clear. The output required to clear the input is 0. To clear the flip-flop is 0 because it is active low. Okay. To get a 0 here, I need to get a 1 here, right? Okay. This is what is 0 required. 0 आया नहीं है. 0 is required. 0 is required for the clear operation. This is a inverter. This is shorted inputs. Okay, this is an inverter. So here I need 1. Acha. Here if you need 1, output of NAND gate is 1. Output of the final NAND gate is 1. Okay, this input is Q3 Q2 ka whole bar. Sorry, Q3 Q2 whole bar, correct? And what is this? This is going to be Q3 Q1 whole bar. Okay, so what is Y equal to? What is Y equal to? NAND of this. NAND means again A into B whole bar. So Q3 Q2 bar multiplied by Q3 Q1 bar whole bar. A into B whole bar, where this is the AB input. By the De Morgan's law, we will open this and this is going to become Q3 Q2. This is going to become Q3 Q2 plus Q3 Q1. Q3 Q2 plus Q3 Q1. Clear? Okay. So flip-flop will toggle if the flip-flop will toggle, right, if Y is equal to, what is the value of Y required? 1. What is the value of Y required? Is 1. Okay. What you need? Y, which is Q3 Q2 plus Q3 Q1, okay, which is also written as Q3 common Q2 plus Q1 equal to 1. अब ये कब 1 होगा? अब ये कब 1 होगा? What I have told you that it is a up counter ना, what I have just explained you, it is a up counter. Okay, so let me write down that up pattern. Okay, Q3, Q2, Q1, Q0. Okay, starts from 0 0 0 0, next will be 0 0 0 1 and etc. Okay, now for this to be 1, very clearly Q3 should also be 1, because if Q3 is 0, 0 into anything will be 0. So first what you need is Q3 तो 1 होना चाहिए. Okay, Q3 तो 1 होना चाहिए. So make Q3 equal to 1. Okay, so 1 0 0. Let's come to 1 0 0. Okay, but Q3 तो 1 हुआ. Q2 plus Q1. Okay, 0 plus 0 will be 0. Okay, 0 plus 0 will be 0. Next is 0 0 1 0 0 1. Still Q2 and Q1 are 0 plus 0 will be 0. Next देखेंगे 1 0 1 0 1 0 1 0. Please note that ये रहा Q2 and Q1. Q2 plus Q1. 0 plus 1 is 1. 0 plus 1 is 1. Q3 is already 1. So here y will be equal to 1. Here y will be equal to 1. Can I say here y will be equal to 1? Right. Here y will be 1. Now, should I count next? No. Whenever y is equal to 1, what I told you, it is asynchronous. That means without even waiting for the next clock, all flip-flops will reset. Okay. So, whenever y is equal to 1, all flip-flops, because this output goes to all the flip-flops. You have to see that. Okay. So, all the flip-flops will reset immediately without waiting for the next clock. Okay, that means what is the next state? That means next state is 0 0 0 0. Okay, the next state is 0 0 0 0. Let me write this here, 0 0 0 0. Yeah, let's not write it here, already it is mentioned. The next state is 0 0 0 0. That means we go to the initial state. Okay, the counting restarts. So what is the mod number? Okay, 0 1, देखो, this is decimal 0, decimal 1, etc. 1 0 0 is 8, 1 0 0 1 9, 1 0 0 1, 1 0 1 0 is 10, right? Now please think, up to what you have to count. Is it 0 to 10 or it's 0 to 9? Guys, it's going to be 0 to, देखो, whenever the state is 1 0 1 0, one last very important point. Whenever the state is 1 0 1 0, output will be, the flip-flops will reset immediately without waiting for next clock. That means this state will come but go away quickly. It will not remain for one clock cycle. Because flip-flops will reset immediately. Okay, so ye state aaya. Okay, but this is not to be counted. So I can make a special remarks here, right? 1 0 1 0. Okay, 1 0 1 0 doesn't stay for one clock period. 1 0 1 0 doesn't stay for one clock period, so it is not counted. So what is the state sequence? Then what are the states? I count from 0 0 0 0, right, up to 1 0 0 1. Up to 1 0 0 1, and hence it is mod 10. Okay, mod 10, or it is also 0 to 9, 0 0 0 0 0 to 1 0 0 1. Okay, and 0 0 0 0 to 1 0 0 1 is also the BCD code sequence. BCD also is from 0 to 9. Huh? Okay, so this can also be named as a BCD counter. Dear. Okay, as of now they were asking only the mod number. It is a mod 10 counter. This one is known as a mod 10 counter. By chance, just for knowledge you should know. Okay, by chance, right, if they mention कि जो clear input है, clear या reset जो भी बोला जाए, right, if the clear or reset input is also given to be synchronous, okay, इसको conclude ही कर देते हैं. If the clear or reset input is also given to be synchronous, see, if nothing is given, by default asynchronous, right, then, but if it is given to be synchronous additionally to design the question, okay, then your answer will be mod 11. Then your answer will be mod 11. Your states will be 0, 0, 0, 0 up to 1, 0, 1, 0. Your state will be up to 1, 0, 1, 0. From 0, 0, 0, 0 up to 1, 0, 1, 0, your states will be there. Why? Because 1, 0, 1, 0 will stay for one clock period, because the reset pin is also synchronized with the clock. That means all the flip-flops will reset, but not immediately, only on the arrival of next clock. So that means this will also be active for one clock, and hence it is a valid state, and hence it is to be counted. And hence it is to be counted. Alright dear, let's move ahead to the next. Okay, and I'll just give you one more similar variety as a homework activity, because it is again on the ripple counter. It is on the ripple counter along with along with that same reset clear functionalities. Okay, along with the reset clear functionality. This time they have given you that I need a modulo 6 ripple counter. Okay, so mod 6 counter is desired. Okay, what should be the type of gate used to derive the clear input? To derive the clear input. To derive the clear input. ये ध्यान रखना, the input to the gate is B bar and C bar. The input to the gate is B bar, C bar, and suppose the output is Y. You need Y equal to 0. Again active low, right? What you need? Y equal to 0 to reset the flip-flops. Okay, but when do you need Y equal to 0? Think modulo 6 chahiye, and assume asynchronous reset only. Okay, assume asynchronous reset only by default if nothing is mentioned. Okay, so slightly reverse question, but easy one only. This is a homework for you. Try out the homework and mention the answer in the comment box. And now let's move ahead to then another question. Let's move ahead to some another question now. Yeah, guys, a fundamental MSQ question. A fundamental MSQ question. The input clock frequency of 60 megahertz is given to a cascaded combination of mod 5 and mod 15 counter. Output frequency will be how much? Okay, output frequency. So dear, एक ऑप्शन से समझते हैं. Output frequency will be how much? चलो इसको calculate करना है. Forget this. Let's come to the next. Minimum clock frequency that to be used for n state ripple counter, okay, is given by 1 upon n TPD. Is it correct? Where TPD is the delay of each stage, each flip-flop. I took as TFF. You can also call it as TPD, no problem. Right? TPD is the propagation delay of each flip-flop. Okay, and the clock frequency is 1 upon n TPD. Is it correct formula? It is the correct formula for maximum clock frequency, not for minimum. Okay, this is the formula of maximum. Each and every word will matter. It is false, Chandra. That's what. Sometimes, you know, we are caught. Okay, the maximum clock frequency is given by this formula. Okay, so this becomes false. This becomes false. Okay. Next, the propagation delay of the flip-flop in a ripple counter does not impose the limit on the frequency at which the counter can be clocked. How it does not impose? We have just seen this formulas. Na? Okay, how it does not impose? The frequency at which the counter can be clocked, okay, is always the maximum frequency. We know that means the frequency is less than equal to what? 1 upon NTFF. Okay, the propagation delay of flip-flop definitely will impose the limit. Okay, so this is also false. This is also false. Okay, this is also false. Option number D. In a 4-stage ripple counter, propagation delay of each flip-flop is 30 nanoseconds. Maximum frequency is 8.33 megahertz for which it will work reliably. Calculate कर लेते हैं. ठीक है, calculate कर लेते हैं. तो option number D. First option number D, and A is also to be calculated. Okay, 4-stage ripple counter, na? Okay, what is given? Okay, I need, sorry, where is that question? I need the maximum frequency. Okay, so what is the formula? Directly formula pe chalte, because we have studied very recently. Maximum clock frequency is given by the formula 1 upon NTFF, and it is a 4-stage, so N ka value 4, and TFF, delay of each flip-flop, is given to you as 30 nanoseconds, 30 into 10 power minus 9. Let me figure out how much is this value turning out to be for a, okay, just a second, in megahertz, so we'll take it as 1000 and then let's divide by 120. Yeah, 8.33 it is. Okay, so it is turning out to be 8.33 megahertz. What does the option says? They also say 8.33, so it is true. This one is true. Now option number A, input clock frequency of 60 megahertz is given to a cascaded combination of mod 15 and mod 5 counter. First of all, whenever counters are connected in cascade, the mod numbers are multiplied. Okay, in cascade mod numbers are multiplied. So overall mod number dear will be 75. Overall mod number will be 75. Okay, now the output frequency, right? The output frequency, okay, or the frequency at MSB bit is given by the input clock frequency divided by modulus number. So what is the input clock frequency? 60 megahertz divide by 75, right? Is it 3 megahertz? This is not 3 megahertz. This is definitely not 3 megahertz. This is definitely not 3 megahertz. This is definitely not 3 megahertz. So this is also false. Okay. What is the correct option? देखो ध्यान रखना है, MSQ question है. Which of the statement is or are false? Which of the statement is or are false? So A, B, C are false. The option to be chosen is A, B, C. The option to be chosen is A, B, C. The option to be chosen is A, B, C. Okay. Yeah, Dharmesh will have a separate session on that. Okay. We were planning important topics, and according to ISC, I'm planning ISC previous complete analysis also. 2008 and 2016 वैसा भी करेंगे. We'll take those also very soon. ठीक है, चलो डन है जी, डन है. So complete. Next, which of the statements are false? It is ABC. Let's go ahead to the next question then. Okay, let us go ahead to the next question. Okay, so guys, some questions I will keep adding as homeworks because already I have spent a lot of time in discussing it. This is again a design of counter. Okay, this is a design of counter. The first two problems only I spent a lot of time to cover up the entire concept. Okay, so this is again design. What you have to do? Current state, next state, excitation table. कैसे करना है? Same. It's only 2-bit. Okay, first you have to take the current state, Q2, Q1. Then you have to write down the next state column, Q2 plus Q1 plus. Based on the transition, you have to write down what? Excitation signal, T2 and T1 input. So it is much simpler than the first question. First one was 3-bit, it is only 2-bit. Okay, so this becomes a homework for you. This becomes a homework for you, so that I can show you more variety here. Okay, so that I can show you more variety. It's although 11 questions of counter, but counter with explanation, it definitely takes time. Okay, so whatever repetitive questions I'm giving as homework, you can please manage this. In case any doubt, you can ask me later on through Telegram or in my next sessions. Okay, chaliye, moving ahead to the next. Okay. Yes, definitely, it's definitely going to be successful. We all hope that, the same thing like last in Chandrayaan 2, that Vikram mishappening happened, that will definitely not happen because they have taken important measures from that particular event. So yes, Argya Deep. Okay, and congratulations to all of us. Chalo, to aage chalte hain. Okay, so but the sequences, they've given the sequence 0, 2, 3, 1. So the sequence will be 0, 0, 1, 0, 1, 1, 0, 1, and then 0, 0. This is the sequence desired. So you have to design it up. Okay, next question. Chalo. Now coming to the reverse question. This is also important. Given a synchronous counter, right? Given a synchronous counter. Okay, what will be its count sequence? Okay, here you don't have to design that synchronous counter. See, it is synchronous. Very clearly see it is synchronous because the same clock goes to both the flip-flops. The same clock goes to both the flip-flop. It is a synchronous counter, right dear? It is a synchronous counter. Okay, so you don't have to design. You are already given one synchronous counter, but what is the count sequence? That analysis we have to do. Okay, I'll share you at the end my Telegram link because all these PDFs and all also will go in the Telegram only. Okay, so let's do it up, guys, quickly. Okay, yeah. What is the counting stage? Q1, Q2. Okay, Q1, Q2. This is Q2, so ये J2 होगा. Okay, this is J2 K2 correct, and this is Q2 and Q2 bar. Some type of error with J1 Q1 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 bar. Okay, this is correct. This is J2 K2 Q2 Q2 bar correct. So what is the counting sequence? In what sequence they want? Q1 Q2. So you have to write down the sequence as Q1 Q2 and make a habit. By default start, any device will start by reset state. Any device of course will start from the power on state, that is the reset state. वहीं से आपको start करना है. Okay, you have to start from there. So let's start with the 0 0. So what is going to be the next? What is going to be the next? So see, I will just explain you very clearly. So this is right now 0 0. Okay. Now what is the next state will depend on what is the JK inputs. Na? Will depend on what is the JK input. So see, what is the JK input? Okay, J1 K1, this is coming from Q2 bar. Q2 0 to complement 1. So this is 1 1. And Q1 was 0. So its complement is 1. So J2 1 and K2 1. So देखो, J1 K1 1. All inputs are written in front of you. J1 K1 1. So Q1 will toggle. Right. J2 K2 also 1. 1 1 means toggle. So Q2 will also toggle. So next state is 1 1. Very clearly, dear. The next state is equal to 1 1. कोई problem ही नहीं हुआ. Okay, the next state is 1 1 completed. Chalo. Now next. So let me write down that next state. Now it is 1 1. So their complements also written. 0 goes here and this particular 0 Q2 bar comes on J1 K1. Now see the inputs again, dear. Right. J1 K1 0 0. 0 0 means no change at Q1. No change at Q1. Okay. What is the J2 K2? J0 K1. J0 K1. K1 for reset. So Q2 will reset. Q2 will reset. Okay. Done. Complete. कब तक करना है? Do till you get the repetition, till you get the 0 0. Okay, that will be the complete one cycle. Okay, so now next. Let me write down the next again now. ठीक है? So next state is 1 0. Right? 0 complement 1 here, 1 complement 0. ये 0 यहाँ पे आ गया, and this Q2 bar 1 comes on the J1 K1. Now see the input. J1 K1 1 1. JK1 toggle, तो Q1 will toggle. Okay, it was 1, now becomes 0. Toggle कर दिया. J2 K2. Okay, 0 1. 0 1 is reset. Reset. So reset means again I get the 0 0 and repetition starts. And as I told you, do until you get the repetition. So I've got the repetition. So I can now stop. So what is the count sequence? Okay, what is the count sequence? The count sequence is 0 0 1 1 1 0 back to 0 0 back to 0 0 0 0 1 1 0 0. Okay. Right, 0 0 1 1 0 0. Now it is not necessary. Now it is not necessary that option will also start from 0 0. See, here this option starts from 0 0. See now, Ruby, you are caught. The option starts from 0 0, but does it follow the complete pattern? 0 0 1 1 1 0. 0 0 1 1 1 0. This is wrong. So C is not correct. Okay. Then what is the correct option? Look into this na. 0 0 1 1 1 0. ये तो यहाँ पे भी hidden है ना. Option can start with any particular bit. That will just keep recycling. Na? 0 0 1 1 1 0 0 0. तो वही तो है 0 0 1 1 1 0 0 0 0 0 1 1 1 0. Okay, so that is the correct answer, which is A. That is the correct answer, which is A. C is wrong. Okay, C is wrong. ठीक है जी. ठीक है. चलो, A is the correct answer. So this is how you determine the count sequence. Okay. Now guys, on a similar tone, on a similar note, one more homework question for you. What is the modulus of the following count? What is the modulus of the following count? It's a similar category only. You have to write down, start from 0 0 0 and keep moving ahead. And keep moving ahead. Okay? And keep moving ahead. Okay. So please complete this homework activity. Okay. Let's go to the next question then. Let's go to the next question. Yeah, once again a synchronous counter. Let's look into this and understand this extra logic circuitry. The D flip-flops are initialized to 0 0 0. After one clock cycle, what is the Q1, Q2, Q3? Matlab they are not looking for the complete sequence. Sometimes they can only ask the next sequence, next bit. They don't want the total number of states. They don't want mod number. They don't want the complete cycle. Initially 0 0 0. What is going to be next? Only after one cycle. Okay, but here, so that means this question is mostly on what? This question is mostly on solving this logic circuitry. It is more on logic circuitry. Okay. Okay, so let's solve it up. Okay, let us analyze what this logic circuitry is. Okay, so what is the state? 0 0 0. Okay, or not necessary to solve completely. Okay. Okay, so ये 0 यहाँ पे आ गया ना. See what are the inputs coming up here. Okay, this is 0. And where is x1 coming from? ये 0, this comes to the x1, this 0 comes here, right? This 0 comes here and same 0 comes here. Only one cycle we need to solve. Q2 is 0, so D3 पे भी आ गया 0. Okay. Only thing you need to derive is D2. Only thing is you need to derive D2. तो यहाँ पे आ गया 0. Now this is 0. 0 and 0 का NOR. 0 plus 0 is 0, but complement will become 1. Complement will become 1. It is a NOR gate. Now NOR gate any input high, output will be 0. NOR gate any input high, output will be 0. Again 0 0. तो 0 0 का NOR. 0 plus 0 is 0. Complement के बाद 1. तो Y becomes 1. D2 is 1. Now for any D flip flop, what we know? Question is solved. For any D flip flop, what we know? Q plus is equal to D. For any D flip flop, what we know? Q plus is equal to D. Okay. So that means what is going to be the Q1 plus? That will be D1. D1 पे 0 है. What's going to be the Q2 plus? That's going to be the D2 input. What is the D2 input? 1. What's going to be the Q3 plus? That is the D3 input. That is a D3 input. That is 0, right? So what is Q1, Q2, Q3? What is Q1, Q2, Q3? What is the next state? First लिख लेते हैं. Current state was 0 0 0 and now the next state is 0 1 0. That's your answer. Okay. So this question was like more on logic circuitry rather than real counting. Okay, because it's only one stage to be counted. So it's not more on counting, it's more on this logic circuitry simplification. There's some logic circuitry built using NOR gates. Okay, built using these NOR gates. Clear? Okay, done. So 0 1 0. 0 1 0. Correct answer is B. The correct answer is B. Yes, Chandra. The correct answer here is B. Okay. Okay. We'll come back to 7th, but let me go to the 8th question first. Okay, let me go to this 8th question first. For the circuit shown, the clock frequency is F0. Okay, and duty cycle is 25%. For the signal at the Q, output of the flip-flop, frequency and duty cycle. It's again a good question now based on timing waveform. It's again a good question that is based on the timing waveform. And if you're understanding and enjoying these questions, okay, just put your attendance by hitting the like button. Put down your attendance, all of you guys. Okay, so there is a 2-bit counter, okay, whose LSB will go to the JK input of the flip-flop. Okay, and the clock frequency is F0. Okay, and duty cycle is 20%. Ab dekho, first we have to do the analysis of this particular circuit. There is a 2-bit counter. Okay, there is a 2-bit counter. Suppose Q1, Q0, right, where Q0 is going to be of course known as LSB and Q1 is known as the MSB, right? Q1, Q0 हो गया 0 0 0 1 1 0 1 1. ठीक है? Now J and K are same. J and K are equal. Achha, whenever JK is same, it is just like T. It's just like a T flip flop, na? It's just like T flip flop. Okay, so J and K are same, and whenever JK is same, dear, whenever JK is same, you can call it as, you can simply call it as the T input only. J and K are equal, and that is equal to 2 input, T input, and that is equal to the LSB. That is equal to what? LSB bit. Okay, that is equal to the LSB bit. Okay, Q0. Okay, that is getting the connection from the LSB. Right, dear? Acha. So whatever is the LSB, I will copy to the T input. That is 0, then 1, then 0, then 1. And as per the T input, we know how the flip-flop will respond. Okay, so what is the flip-flop Q output? Okay, let's assume initially 0. Let's assume initially 0. Let Q, this particular Q, equal to 0 initially. By default, reset, na? By default, reset. Okay, so I am starting the output Q. I am starting the output Q by initially reset condition. Okay, by initially reset. Okay, but now the T input comes. Now the T input comes, which is 0. So there is no change. But when the T input is 1, it will toggle. And now T input is 0. So again, no change. No change, matlab previous will copy. Okay, and again T input is 1. If again T input is 1, it will again toggle. Acha, let's see the repetition. The repetition means counter will again go back to 0 0. Okay, that is the repetition. Okay, 0 0. So LSB is 0. T input is 0. T input is 0 means no change. Means no change. Okay, next again 1 आएगा, so it's 1100 type of combination. It's a 1100 type of combination. Okay, it's a 1 clock, for 2 clocks it is 1, for 2 clocks it is 0. Okay, for 2 clocks it is 1, for 2 clocks it is 0. Clear? It is a 1100 combination. Next आ जाएगा 11, next आ जाएगा 00, etc. ठीक है, etc. Okay, 1100 type of combination. Okay, so if I have to separately draw this Q waveform, if I need to separately draw this Q waveform, it's going to be 1100. For 2 clock it is 1, for 2 clocks it is 0, for 2 clocks again it is 1, and 2 clocks again it is 0. That means it is at logic level 1 for 2 clock cycles, it is at logic level 0 for again 2 clock cycles. Okay, so this total period is 2t clock. This is also 2t clock. Ask me if you have any doubts. This is also 2t clock. Okay, this is also 2t clock. Okay, so what is the total time period of the Q waveform? Okay, total time period means again when it becomes 1. Okay, the time for repetition. Okay, so the total time period of the Q waveform, is equal to 4t clock. Okay, so what is the frequency of the Q waveform? Frequency will be reciprocal to 1 upon 4 f clock. 1 upon t clock will be f clock. F clock is given to you as f naught. Okay, so frequency is f naught by 4. Number 1 very point clear. The frequency is f naught by 4. f naught by 4. अच्छा, duty cycle बता दीजिए मुझे. Duty cycle भी पूछा है यहाँ पे. Clock duty cycle is 25%, but that's not going to affect your answer. Clock duty cycle is 25%. So like even if I draw the clock waveform for you, okay, even if I draw, suppose this is the first edge, okay. Positive edge triggered, na? Yeah, everything is positive edge triggered. At every positive edge, transitions at every positive edge results will be seen. So 1 clock period 1, next clock period again 1, next clock period 0, next again 0, 2 1 2 0, 2 1 2 0. Acha, but clock duty cycle was different. I'm sorry, this should not be the clock waveform. But what I'm trying to show you is that clock duty cycle is not going to affect the duty cycle of the output here. Okay, so clock should be something of this kind. Clock duty cycle is only 25%. And etc. Clock duty cycle is 25% only. The clock duty cycle is the 25% only. Okay, but still the output for 1 complete cycle 1, again for 1 complete cycle it is 1, for 2 clock cycles it is 0. Okay, so it is 50% on 50% off. It's a 50% duty cycle. Okay, so यहाँ पे अगर separately मैं लिख दूँ, what's going to be the duty cycle? We know how to calculate that. Duty cycle is the on time period upon total time period multiplied by 100. For how much time it is on? On means level 1. So that is 2t clock. What is our total time period? 4t clock. Total dekha na, 4t clock. Right. So that is 2 by 4, 50%. Duty cycle represents that out of the total time period, how much percentage it is at level 1. It is on. So it's a 50% case. It's a good question based on timing waveform, and the correct answer is A. Okay, okay, so only clock frequency will determine the output frequency, but the duty cycle is only based on the output pattern. It doesn't depend on the clock frequency. It doesn't depend on the clock duty cycle. The output duty cycle can depend on clock duty cycle. If the flip-flop was a latch actually. If it was a level triggered, I mean to say. If the flip-flop is replaced by a latch. Okay, so here if I use a latch which is level triggered, then the duty cycle of the output will depend on the duty cycle of clock. Then it will depend. Think why? I have explained you what is level triggered. Flip-flop wali class ko dekhiye. What is level triggered? What is edge triggered? What is the difference between them? So there it is definitely going to matter. There it is definitely going to matter. ठीक है जी, बढ़िया. Okay, so this is the 8th one. This is the 8th one. Okay, चलो, now let me go back. I skipped the 7th. मैंने कहा पहले अच्छा waveform वाला करते हैं. Now a logical question here. Okay, now a logical question here. The minimum number of JK flip-flops required to construct a synchronous counter with the count sequence. Be very careful. What is the count sequence? 0, 0, 1, 1, 2, 2, 3, 3, 0, 0. Okay. Repetition of count sequence. 3. Repetition of count sequence. 0, 0, 1, 1, 2, 2, 3, 3. Right. How many flip-flops? It's a logical aptitude based question rather than a digital or rather than a synchronous counter question. Aptitude thoda sa lagega yahan pe, because what I think is, what is the unique states? There are 4 unique states, 0, 1, 2, 3. If I discard the repetition, there are 4 unique states, 0, 1, 2, 3. And for 4 states, 2 bits are sufficient. What we normally think, for 4 states, 2 bits are sufficient. Okay, so I have 4 unique states. That is 0, 1, 2, 3. Okay, so for 4 states, definitely 2 bits are sufficient. 0, 0, 0, 1, 1, 0, 1, 1. ठीक है, but यहाँ पे repetition है. But here there is repeated states required. Here there is repeated states required. That means for 2 clock cycles I need 0. For 2 more clock cycles I need 1. Every particular state is desired for 2 clock cycles, but what usually happens in a counter, at every clock cycle, at every clock edge, the state will change. But I want to continue the same state even for the next clock cycle. Okay. So now again you think there are 4 unique states, and again if you do it with Q1, Q0, right? So 0, 0. Next I want again 0, 0, right? Next I want 1, 1. Sorry. Next क्या 1. Okay, so 0, 1. Next again 0, 1. Then 1, 0. Then 1, 0. Then 1, 1. And again 1, 1. And then back to 0, 0. But is this possible? For a particular state, there can be only one next state. Okay, there can only be one next state. So for 0, 0, next state is 0, 0. Now for 0, 0, if you have fixed that next state is 0, 0, so again the next state will be 0, 0 only. Okay, how it can be 1, 1? How it can be 1, 1, na? If you decide that for 0, 0, next state is 0, 0, 0, then again next state will be 0, 0. So again will be 0, 0, 0, 0. Problem will be lockout. The counter will be locked at 0, 0. Okay. So although here again there are only 4 unique states, but with repetition. So with 2 flip-flops, design not possible. Design not possible with 2 flip-flops. Yes, Chandra, correct. Design not possible with 2 flip-flops. Okay. Right. We need to just take one more bit. The logic is we need an extra bit to distinguish, okay, 0, 0 and 0, 0. Right, and similarly distinguish 0, 1 and 0, 1. There are 2 0 zeros, so इनको distinguish करना पड़ेगा. Right, that means there is one extra bit and one extra flip-flop. Okay, and now see, it is something like this: 0, 0. Let me only write down Q1, Q0. Let me only write down Q2, Q1. Okay, then 0, 1, then 0, 1, then 1, 0, then 1, 0, then 1, 1, then 1, 1. Okay, but there are 2 0, 0, na? At one of them Q2 will be 0, at one of them Q2 will be 1. Similarly, again Q2 will be 0 and 1. Again Q2 will be 0, 1. Again Q2 will be 0, 1. Okay. Distinguish. One bit can have 2 states, 0 or 1, 0 or 1. That's what I am doing here. That's what I am doing here. Clear? Right. Okay. And all of the states are now unique. All of the states are now unique. This is 0, 4, 1, 5, 2, 6, 3, 7. If written in decimal, all the states are unique. Okay, so this can be designed using 3 flip-flops. Then you will say, sir, it is a 3-bit counter. Where it is 2-bit? I will tell you. Okay. The design is possible. Design is definitely possible using 3 flip-flops. 2 से तो नहीं हो सकता. ठीक है. Design is possible using 3 flip-flops. ठीक है. And only consider Q1, Q0 as output pins. Matlab, whenever you design the IC of it, whenever you fabricate this, okay, whenever you give it for fabrication, okay, and whenever you get this IC, what you should do, that IC should only have 2 output pins. The third, there is actually 3 output pins, but one will be hidden within the IC. Okay, one will be hidden. There will be no extra pin given for it. Okay, there will be 3 flip-flops, out of which Q1, Q0 output will be provided in the IC. Okay, and Q2 will be hidden internally in the circuit. Okay, right. So for a user, what will be the output? Q1, Q0. बाहर क्या दिखेगा? Output pin में केवल Q1, Q0. So first clock 0, 0, again 0, 0. You got this, na? Internally there is a difference between them. Internally there will be a difference between them. Okay. But what does a user see? First clock 0, 0, again 0, 0, then 0, 1, and then 0, 1. So we have made the design possible, and eventually what is the answer, dear? Eventually the answer is 3 flip-flops. Eventually the answer is 3, right? A numerical type question I have made, the answer is 3. The minimum number of flip-flops required to construct this is 3. Okay. Mod number doesn't make much sense here, but to put on it will be really 8 only. Okay, because the final repetition occurs, okay, after 8 states only. Okay, Chandra. Chalo. That's the logic of solving this question. That's the logic of solving this question. Okay. Acha, if this question is clear na, I will give you one more homework. If this question is clear, I will give you one more homework. Okay. Now tell me number of flip-flops. Okay, number of flip-flops for the pattern. So the pattern is 0, 1, 0, 2, 0, 3, and then repeat. 0, 1, 0, 2, 0, 3. Okay. So every alternate sequence is 0. ये decimal में लिखा है मैंने. Okay, ये decimal में लिखा है. That means 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, etc., etc., etc. Okay, ये homework करके आना. Please do this homework. So again, a good question, but if you have understood previous, ये भी आ जाएगा. Okay, ये भी आ जाएगा. Please think in this direction that the 0 is going to be repeated 3 times. In the entire cycle, the 0 is going to be repeated 3 times. So how do you tackle with that repetition? How do you tackle with that repetition? वो आपको समझ में आना है. ठीक है. चलो 8th question is already solved. Okay, 9th question is also solved. ये पहले ही कर लिया था हमने ripple counter पे asynchronous clear input के साथ. Okay. Similar to this, 10th question was given as homework. So I hope you will try it out. You will put your efforts. Okay. Now 11th question. Okay. 11th question, guys, come to this. The control signal functions of a 4-bit binary counter are given below, where X's don't care, and the counter is connected as follows. Okay, the counter is connected as follows. Assume that the counter and gate delays are negligible. Okay, if the counter starts at 0, it will cycle through the following sequence. Now let's understand this table. Kya given hai? The control signal functions are given to you. Some control signal functions of a 4-bit binary counter are given to you. Now look into this. Okay, look into this. Clear. If the clear is 1, X is what? X's don't care. It simply means that if clear is 1, इसको यहाँ समझते हैं, थोड़ा सा आगे आ जाते हैं. Look into this clear table. Okay, if clear is 1, okay, clock, load, X don't care. मतलब whatever may be clock or load or count, I do not care. Okay, the function is clear to 0. So this is like a clear pin, reset pin that I already explained you in the previous questions. This is just a reset pin. But what type of reset? Active high. Active high. Will it wait for the clock? No. Independent of clock, whenever clear input is 1, the flip-flop will be reset to 0. The function is clear to 0. So what type of pin is this? What type of pin is this? It is a... What type of pin is this? This is a asynchronous but active high. Active high. Whenever you send 1, then only the function will be clear to 0. It is a asynchronous active high clear या reset input. ठीक है जी? That we have already discussed in the previous question. Okay, that we have discussed in the previous question. ठीक है? Right. Now what is next? So if clear is 0, now we need to think about rest. ठीक है? Now, when will the counter count? Okay, when there is a clock edge coming up. When there is the clock edge coming up. So look into this. Look into the last. Okay. If the clear is 0. Okay. And if the clock edge, positive edge. What is this? Positive edge comes. Okay. Okay. And I make the count input as high. Okay. Then I will count next. Oh, sorry. This is not clear next. This is count next. This is a typo error. This is count next. Not clear next, count next. ठीक है? This is count next. This is known as count next. Clear? ठीक है, तो अगर clock 1 है और count 1 है, okay, clock 1 means clock positive edge is there, and if the signal to count is given, the flip flop, the counter will count next. That means if it is 1, it will go to 2, 2 ka 3, 3 ka 4, etc. Okay. Now look into the third one. Okay, clear input is 0, clock positive edge is given to you. Okay, and then a load input is given to you. Then count input goes in the don't care condition. Count input goes in don't care. That means whenever load is 1, it will not count next, it will load a input. So there is an additional feature of loading a direct input here. Okay, if loading a direct feature here. So see guys, forget the recent value. देखो, अगर count को आपने 1 किया हुआ है, तो it will count next. But if you have made the load input as 1, here it is given to be 0. But assume, understand करो पहले, if the load input is given as 1, it will not count next. It will take whatever is the input supplied here, it will take and transfer to the output. So output will directly be this value randomly. So this is a value, this is a case when you can randomly start the counter from a particular value by loading that particular value. By loading that particular value. Okay. So if the load input is 1 independent of count, so that means it has lower priority, higher priority is for load. If load is 1 independent of whatever the count is, I will not count next. Okay, I am going to load the input. I am going to what? Load the input. Clear? ठीक है जी, ठीक है. Now let's come to the second row. Only the second row is left. Okay. So clear is also not there. Load is also not there. Count is also not there. Clock edge is also not there. So of course, sit idle, no change, because change can only occur with the clock edge. So second row means there is no change, no activity to happen. No activity to happen. Okay. Now. Initial state is 0. If the counter starts with 0, okay, it cycles through the following sequence. Now let's look into this very clear picture. Let's look into this very clear picture that count is given to be 1, okay, and load is 0. Count 1 hai, right? Load 0 hai. Okay. Okay, so there is, if the load input is 0, there is no role of this input. Because load 0 hai na, so there is no role of the input. There is no role of the input. This will only be used if the load input is made high. If the load input is made high. If the load input is made high. Okay. Okay. Now, there is the role of clear input, but how the clear input is derived? It is again through an AND gate where the inputs are A3 and A1. So output of AND gate is A3, A1. Okay. Output is A3, A1, and suppose this is X, which is A3, A1. X nahi bolte hain, X is already used for don't care. Suppose this is variable Y. Suppose this is the variable Y, which is equal to the A3, A1. Clear everybody? Now what to do there? The counter starts with 0. So now let me write down. A4, A3, A2, A1. A4, A3, A2, A1, 0, 0, 0, 0. Okay, and now the clear input will only be active. The clear input will only be active when A3, A1 is high. Y is equal to product of A3, A1, right? So when both A3 and A1 is high, output Y will be high, then only clear will be active, right? So we need to keep a watch of A3, A1 as well. We need to keep a watch of A3, A1. Right now they are at 0, so counter will count next. Why it is going to count next? Because count is already given. Count is high, so on the positive edge of the clock, it will keep counting. So next is 0, 0, 0, 1, right? Count next, 0, 0, 1, 0. Count next, 0, 0, 1, 1. Count the next and 0, 1, 0, 0. Count the next 0, 1, 0, 1. Now please stop here, because what I told you, we have to keep an eye on A3, A1. Whenever the counter reaches this state 0, 1, 0, 1, what I am able to encounter is that Y becomes 1. 0, 1, 0, 1. A3, A1. Product A3, A1 will be 1. Y is equal to 1. Y is equal to 1. Right. So counter will reset. When it will reset? When it will reset? Immediately. When it will reset? Immediately, without waiting for the next clock. Right. So what is the next state? So what is going to be the next state? It will reset. That means 0, 0, 0, 0. And my device restarts. So what is the mod number? Okay, whenever it is asynchronous reset design, do I need to count this? No, because this state appears for a very short duration of time and hence practically it cannot be counted. So my mod number is 1, 2, 3, 4. It's a mod 5 counter and the sequence is, it's a mod 5 counter having the sequence, if I write in decimal, it's 0, 1, 2, 3, 4. It cycles through 0, 1, 2, 3, 4. Okay, and back to 0. back to 0. Let me go through the options here. It cycles to 0, 1, 2, 3, 4, but not 5. See, very clearly, very smartly, one option is given, that is 5, but that is not to be included. That is to be included if it was a synchronous clear input. Why it is asynchronous clear input? I have explained you. By reading the table, I have got the analysis that it is asynchronous. Okay, because as soon as clear is 1, independent of everything else, okay, the function is clear to 0. The function is clear to 0. Right, everybody, and this is completed. This is completed. The correct answer is C. The very correct answer for the question here is the C. Okay, hope you have understood this. Hope you have understood this. ठीक है जी, done. Done. ठीक है. Now, this was the 11th question. Yeah, that's it. So we are done with 11 questions, out of which 2-3 I have given you as homeworks as well. Hope you have got the session went on for a good amount of time. It's more than 1.5 hour, but yeah, the initial part itself took some time when we were discussing some fundamental questions of counter. That itself took a little bit of time, but that's okay. We've understood counter definitely takes time. One of the very important topic for the examination it is. Okay, and now it's the time. I'll also provide you with the password for the PDF, because this entire PDF with all question, all solution discussed, okay, will be there in the Telegram. Okay, and the password is going to be count for counter. Okay, very small letters, count, COUNT. It's going to be count. Okay, everything in small. You will get the PDF in my Telegram group. Okay, for both the previous 2 sessions, that is 11 questions on flip-flop and FSM, PDF is shared in the Telegram. Both the PDFs today morning I have shared in the Telegram. Okay, night I could not share. Okay, so yesterday night and day before yesterday, both the PDFs in the Telegram. If you are there, it will be there, right? Sure, GATE aspirant, I'll definitely plan one. Okay, this is the count. Now next is what? Okay, now next in the monsoon course, I'll tell you 2 important updates, guys. Okay, in the monsoon course, okay, the next activity that will be from Monday, right? For ECE, it's going to be control systems. It's going to be control systems by all your favorite Ashu Jhangra sir. Okay, and for computer science, it's going to be programming. Okay, important expected topics of programming. Okay, once again by all your favorite, that is Satyanarayan sir. Okay, that will be for computer science. Okay, that will be Monday. Okay, now also if you want to attend some of my other sessions, so on the app again from Monday, these are some of my other classes. So Monday I am having classes on the app, guys, so you can join me on the app, BYJU'S exam prep app. You can download it immediately. If you have not downloaded till now, you can get it easily from the Google Play Store. So I bring to you a Super 11 series for signal and system. Okay, like this 11 questions. So although it was 11 question of counter, but I think, okay, you have also learned several concepts. It was not only question. Similar philosophy, I have a complete Super 11 series that's going to start Monday. Okay, every day at 7 p.m. Although Tuesday it will not be there, because Tuesday it is the workshop, already I told you, na? Tuesday we have the workshop. Okay, so Monday, Wednesday, Thursday, Friday, 11 questions on Fourier transform, 11 questions on Z transform, 11 questions on DTFT, 11 questions of Laplace transform. The 11 finest questions selected to make your entire chapter complete, like Z transform, like Fourier, like DTFT, and like Laplace. So 4 major topics of signal and system you can cover on the BYJU'S exam prep app. But be very aware that this is on the app. I will share you the link of this session also on the Telegram. I'll share you the session of this also on the Telegram. Okay, I'll share it on the Telegram. I'll share you the PDF of today and the upcoming session links on the Telegram. Just stay connected on the Telegram, and here it is, the Telegram link. This is the Telegram link, guys. Okay, you can connect to me in the Telegram, right? Yes, Chandra, we'll plan Menti sessions also. Okay, chalo guys, so that's it. Bye bye. Thank you. Stay safe. See you now on Monday. Also, Sunday also there is a session that I have planned for you. So let me update you that also. Sunday 11 a.m. As always, as regularly Sunday 11 a.m. Every Sunday 11 a.m. I am taking something related to general aptitude. You know, if you are subscribed to the channel, every Sunday continuously from last so many Sunday at 11 a.m. I am taking something related to general aptitude, and this time I am taking a session on general aptitude where we will take up a sample question paper. Okay, sample question paper as per gate pattern. Gate pattern means 10 questions, 15 marks. Exactly whatever is the pattern of gate, including quant, logical reasoning, verbal ability, spatial aptitude, including everything. A 10 question sample paper. See what's your score right now in general aptitude, how much you need to improve. You can check your score and see where you stand in general aptitude right now. It's like a general aptitude mock. It's a general aptitude mock. Okay. So that's Sunday 11 a.m. So that's why just subscribe to the channel so that you don't miss any of this. You by default get updated about the sessions, guys. See you Sunday 11 a.m. Bye bye. Thank you. Stay safe and take care of yourself. Good night.